Welcome, everybody, to this presentation hosted by the Santa Cruz Museum of Natural History. My name is Marisa Gomez, and I'm the Public Programs Manager at the museum. And it is my delight to put together online programs like this one tonight for our community, in addition to safe outdoor adventures. We got one going on this weekend that there's still a spot for if that suits your fancy. So you can maybe look into that. But I'd also like to acknowledge that Santa Cruz County has entered the red tier of the state's phased reopening plan, which means that museums are allowed to operate indoors now as well as outdoors and online. So if you're not already subscribed, I would encourage you to sign up for our biweekly newsletter so that you can stay updated on our reopening plans. So I did want to just make sure that I acknowledged that, because yeah, lots of questions buzzing about how this is all going to happen. But in the meantime, we're still doing our online programming and in-person outdoor programming like tonight. And before we get too far into things, I did want to make sure that we are all able to communicate with each other tonight. Your video and mic are disabled for this webinar, so we are going to be communicating tonight via the chat. There's also a Q&A function available. I think I forgot I stopped sharing my screen. I want to make sure you can see this. So there's also a Q&A function available for asking questions, and we'll get to those at the end of the presentation. We also might have an opportunity for you to chime in verbally with your own voice at the end to ask questions too, if you're interested in that. But for now, we're going to be focusing on the chat. And we want to make sure that we can see what it is that you have to share, but also everyone streaming in too, not just the presenters. So if you could do me a favor and quickly go to your chat area and click on where it says to panelists and change it over to panelists and attendees. That way everyone can see what you have to share. And I am especially interested in hearing your memories about the tsunami, which we are talking about tonight. I'm sure a lot of the people joining us for this lecture were in Santa Cruz County 10 years ago today when this tsunami event impacted Santa Cruz. So practice using the chat, sending to panelists and attendees, and let us know what you remember from that day. What did it feel like? What did you see? What did you do? So I look forward to reading those. And I also wanted to take a moment to acknowledge that the land from which I am joining you and the land on which the Santa Cruz Museum of Natural History resides is the traditional and unceded territory of the Yupi tribe of the Awaswas Nation. And today these lands are stewarded by the Amamutsan tribal band, who are working hard to fulfill their obligation to Creator, to care for and steward Mother Earth and all living things through relearning efforts and the Amamutsan Land Trust. And these are members of the Land Trust here in this picture. And without further ado, let's talk tsunamis. So I'm going to be welcoming in our presenters now. And tonight we are going to be hearing from Heather Savage, Associate Professor of Earth and Planetary Sciences at UC Santa Cruz, and Kristina Okamoto, a graduate student with the same department. And they both work with the Seismological Laboratory on campus, the Seismo Lab, who the museum has partnered with in the past. If you remember our exhibit commemorating the 30th anniversary of the Loma Prieta earthquake a few years back, that was with the Seismology Lab. And Professor Heather Savage's research focuses on earthquakes and faults, and she uses field observations of fault structure, particularly mapping earthquakes, slip and fault damage zones, to provide windows into the processes that occur during earthquakes, such as heat production and chemical reaction that affect fault zone mechanics. Really interesting stuff. And Kristina Okamoto is currently studying an induced earthquake sequence in Prague, Oklahoma, in order to analyze the mechanics of earthquakes. And she also uses laboratory experiments to explore the physics of friction at conditions relevant to earthquake depths. And we're going to be hearing from both of them today, but I believe we're going to be starting with Kristina. So thank you both for joining us and for taking the time to do this. We can't wait to hear what you have to share about this really historic event. And Kristina, why don't you take it away?
Thank you. Let me share the screen. Okay. There. Thank you, Marisa, for the introduction and for putting this event on. I'm Kristina. I'm a graduate student at UC Santa Cruz. I'm excited to talk to you today on the 10th anniversary of the Tohoku-oki earthquake. Heather and I will discuss how earthquakes and tsunamis occur. We'll describe how large this very large event was. And finally, we'll discuss the impact that this event had on Japan and areas around the Pacific Ocean, such as right here in Santa Cruz. To start off, we'll watch a video of the shaking that occurred in Japan, since most likely very few of us, have experienced an earthquake this large. So here's the shaking video. This is taken in the Sendai airport, which is just off the coast of, just along the coast of where the earthquake hit. And so you can see the shaking was incredibly intense, lasts for a pretty long time, and is pretty terrifying. So first I want to take a step back and look at why earthquakes occur. So earthquakes occur because of plate tectonics, where the earth is composed of these different plates and they're all moving, where, so here the Pacific plate is moving kind of northwest, and it causes shear along the San Andreas fault, which is here. And in other areas, plate tectonics causes, has a divergent boundary, such as at the Mid-Atlantic Ridge. And so that's where plates are being pulled apart and new ocean crust is being made. In other areas, such as the rest along the Ring of Fire, the Pacific plate is diving beneath these other plates here. So they're converging. And earthquakes happen because of basically these faults moving, these plates moving against each other, and as they move, they can get stuck and accumulate energy. And then as the stress on the fault increases, it can then slip in an earthquake. And during that earthquake, the movement along the fault generates seismic waves, and those are the waves that we feel during the earthquake. And so here, again, we have the Pacific plate diving underneath what is the North American plate, and where Japan is. And as it slides, it can get stuck and cause these big events, such as the Tohoku event. So how big was the Tohoku event? It's measured to be a magnitude 9.1. The duration was 6 minutes. So that's how long you could feel the shaking. It's the fourth largest earthquake ever recorded with modern instruments. And you can see the slip area here, which is 400 kilometers long and 200 kilometers wide, with the colors indicating how much slip occurred. So this red, deep red color shows 50 to 70 meters of slip, whereas the lighter colors are less. And this event also changed the mass of the Earth, redistributed the mass, so that it actually spun faster by 1.6 microseconds to shorten the day. Yeah, it shortened the day by 1.6 microseconds because of that. And just to put that area into perspective, the slip patch imposed onto California, which shows that it would extend from the coast to the Sierra Nevadas. And the largest amount of slip, that 50 meters, which is equivalent to half a football field, extends from Santa Cruz to San Francisco. So imagine that whole area basically slipping half a football field. It's pretty terrifying. So we showed how big that the Tohoku earthquake is. This is a 9.1. And just to understand the magnitude scale, each step up in magnitude is equivalent to 10 times the amount of the size of the event. And it's 30 times the amount of energy for each step up. For this, the reason why many of us haven't felt magnitude 9 events is because there's very few of them. There's less than 1 per year, whereas these smaller earthquakes, like a magnitude 2, there's like 1 million per year. So these events are very rare. And just to show that again, we have the, you can see the San Francisco earthquake in 1906, which was the biggest event in California in the 1900s. That's about 10 times smaller than the central Chile event, which was a magnitude 8.8. And so you can see these are some of the largest events that have occurred, where the Tohoku event is here, and then the largest event ever was the 1960 Chile event, magnitude 9.5. So the amount of shaking, I guess a lot of you might have been around for Loma Prieta, which was a magnitude 6.9. And so you can imagine that the amount of shaking that larger one would occurred would have been a lot more. But it should also be noted that this Haiti event, which a lot of us remember from 2010, it actually caused over 100,000 deaths. The Tohoku event caused about 15,000 deaths. So even though this is much smaller slip area, it can cause still a lot of damage, and a lot of it has to do with infrastructure. So we've talked about how earthquakes occur, but the second part of this event was a tsunami, right? That was the most damaging part of the Tohoku event. And so I just want to talk about how tsunamis happen. So here you see this oceanic plate diving beneath the continental plate, and there's this locked patch. It's stuck, it's pulling the continental plate inward. And then in an earthquake, it slips back up, it displaces the ocean floor, and that's what causes the tsunami. And now I'll pass it over to Heather to talk about the effects of this tsunami in Japan.
Thanks, Kristina. So as Kristina said, the sort of infrastructure in an area has a real impact on how much damage actually happens during these events. And Japan is one of, if not the most prepared nations in the world for seismic hazards. So for instance, what we're looking at here is a seawall that was built to prevent tsunamis from inundating this road here. Unfortunately, it was not anticipated that a tsunami as large as the one occurred was possible. So the seawall was not built to withstand the size tsunami that occurred. Next slide. So here we can see that wave inundating, going right over that seawall. Next slide. Here's an overview of the whole wave crashing into the shore here. Just for reference, the shore is actually out by like where the water becomes white and foamy. You can see the trees popping out right near where it becomes white and foamy. So it's already inundated quite a bit of land, and it's moving towards the right of your screen. Next slide. These waves are massive, and they are capable of picking up and moving very large objects. For instance, this very large ship here that is now back on land. Next slide. And in many cases, they put buildings were sort of ripped right off of their foundations and completely destroyed, where you can see the remnants of a bunch of foundations where there used to be buildings here. Next slide. Here we see the wave coming in. So all this sort of like black gunk in the middle of the photo is the wave coming into the Sendai airport, where we saw that shaking video in the beginning. And we're going to return to that video. It's going to be a few minutes after where we left off. And we're going to actually see the wave roll in. So you can see it in the distance. Let's try that again. So we see it coming in the distance there. So one of the things as it gets closer that you might be able to see is that it is not, in fact, just water at this point coming in. You can see that sort of black wave. It's really sludgy at this point, sort of moving forward. And you know, everything in its path is now picked up and part of this wave. So you have trees and cars and massive amounts of debris that are now part of the tsunami. So incredibly destructive force coming through. Next slide. So unfortunately, one of the worst things that happened during the tsunami is that the Fukushima Daiichi nuclear power plant was also inundated. So again, this area had a seawall, and the wave toppled the seawall. And because Japan is so earthquake aware, they have so many earthquakes. All of their systems, especially systems like nuclear power plants, as soon as the shaking started, they automatically get turned off. And however, they need power, usually in the form of backup generators, to keep things cool. So you're constantly circulating seawater through the cooling tanks for the spent rods. And unfortunately, in this case, the backup generators at the plant were located at a low level. So they were inundated by the tsunami as well and knocked out. And the nuclear, and there was a nuclear meltdown after an explosion, which we see here. Moving on, the sort of skipping it. That's okay. It's okay. You can skip to the next slide. So in terms of like, how has this region returned to what kind of life they have at this point? Here's a sort of split screen where we see the debris like right after the event, and there's that large ship again that was placed on land, and it took years even to just clean up a lot of that debris. And you can see that that sort of effort has been achieved, but you can still see that a lot of the rebuilding hasn't actually happened yet. You can see lots of foundations with nothing built on top. You go to the next slide. And then sort of more lasting effects as well. The nuclear power plant meltdown, Fukushima, it continues to be a problem throughout the area. Initially, over 100,000 people were evacuated due to the nuclear meltdown, and many regions, like sort of, you know, think of like regions surrounding that power plant were kept closed for years. And so in some places, like at the power plant itself, they're still dealing with all the nuclear waste that they cleaned up. So what we're actually looking at on this photo on the left, these sort of squares of black, there are garbage bags piled on top of one another of nuclear waste. And they've been working, this photo's from 2016, there's been some progress since then, but they're working on trying to find where to put all of this stuff. And then on the right here, we see a new seawall, a bigger seawall has been built, but then not a lot of things behind it, as you can see on the other side of the seawall. And one of the problems that really still plagues the area is that many people were forced to leave after the meltdown, and many people have not returned. So it was already a fairly rural area, and they're still sort of reeling from the loss of their population. So it's a place that will be impacted for some time to come. Okay, next slide. So like we saw in that cartoon, tsunamis get generated at a place where an earthquake occurs, but they don't stay there. So if you go to next slide. So this is an image of the Pacific Ocean and the height of the tsunami that occurred during Tohoku. So all the way over by Japan, you can see that the highest, so we have a little scale bar on the bottom, that's wave height in centimeters. And you can see that the black part is the right where the earthquake occurred is the highest wave height that was generated. And that highest wave height was about 39 meters. So close to something like 120 feet. So pretty, we'll talk about inundation and what you should do in an earthquake, in a tsunami to get to safety in a little bit. But think about how high getting up 120 feet is from sea level. It's pretty impressive. And then as the colors change, we're looking at lower and lower heights, but you can see that it's spreading out over throughout the Pacific Ocean, and was felt in Hawaii and many other places, and even hit us all the way over in California. And specifically, Santa Cruz sustained some of the most damage in the state from this. About $20 million in damage occurred during this earthquake or tsunami. Next slide. So we're gonna watch, so here's Cowles. I'm sure everyone recognizes Cowles. And we see our wharf right there. And then beyond that, we see the boardwalk. And this is going to be a time lapse of Cowles. So we see 8:44 a.m. The tsunami hit here about 10 hours after the earthquake. It took it that long to travel across the Pacific Ocean. So what we're going to see in this time lapse is the waves pull out, and then the wave come crashing back in, sort of sloshing back and forth a few times. So here's 8:44 a.m. Note where like the rocks are. So here the waves pulled way back. We see a lot more sand and rocks at 8:46. And then 8:51, let's pull it back a bit further. 8:53, it's starting to come back in. Note all the surfers now showing up. 8:54, we're crashing back into the cliff. 8:58, we're fully inundated. We don't even see the seafloor. So 9:08, still crashing. 9:16, we're starting to pull back out again. And it's just going to keep going out now. 9:21, more surfers showing up. 9:22. And there's a slightly different view. So, so that was Cowles. Now we're going to, but the place that was most impacted in Santa Cruz was Santa Cruz Harbor. And so the wave came into Santa Cruz Harbor, as we're going to see in this video. And basically any boat that, or, and docks and what have you, that were in its path basically just got tossed around, as you can see, and slammed into one another. And there was a lot of damage from that. So like I said, by the time the wave hit Santa Cruz, it was only 3 feet high, so about 1 meter. So significantly smaller than it was over in Japan, of course. But it still managed to do quite a bit of damage here, as I said. If we go to the next slide. So we know that, we all know we have risks of earthquakes here, and probably most of you already know that we have tsunami risk, both from faraway sources like Japan or the Aleutians in Alaska, or up in the Pacific Northwest from the Cascadia subduction zone. And we also have more local sources as well. And this is an inundation, a possible sort of large, I won't necessarily say it's maximum, although it says on the slide, a very large tsunami possibility that was put together, modeling all those sort of different sources, both local and far away, that could impact our area. And so this is a much more inundation than we saw. This is probably around more like 10 meters of inundation, 10 to 15-ish. Into town. So you can see sort of the low-lying areas you might expect could be vulnerable, like San Lorenzo River and the harbor, as we already saw, but then, natural bridges, but then we also see places we don't really think of as being like low ground, like Westcliff Drive can also be impacted if we have an event like this. Next slide. So the other more local faults, so we have some offshore faults right nearby. So here we are down in Santa Cruz. One of them is the San Gregorio fault, and then we have some smaller faults in the Monterey Bay as well. Now, we don't expect that these faults should have earthquakes as large as what we saw in Tohoku. But because they're nearby, they don't need to make a magnitude 9 earthquake to make a massive tsunami. We could have a big tsunami we could have a tsunami here as long as they move the seafloor like we saw in that cartoon. Finally, I'll say that another source of local tsunami that we have is submarine landslides. So that can also movement from the landslide can also generate tsunami. So what should we do? We should know what we do to prepare ourselves for a tsunami, for earthquake and tsunami. Of course, if you feel an earthquake, I hope you all know what to do. You get under something nice and sturdy like a table, and you stay there until the shaking is over. That's the best way to keep from getting hurt by things falling on you. So the thing to remember is drop, cover, and hold on. Now, this is true, for if you feel shaking. If you happen to be in a low-lying area, like a beach, like we're just looking, if you see one of those tsunami signs when you're out at the beach, and you feel an earthquake at the beach, you should stay put until the shaking stops. And then as soon as you can, you should get to higher ground, because it could be an earthquake that happened on one of our other faults, say like the San Andreas, where you probably won't have a tsunami associated with it. But it could be, but you could have a tsunami associated with an earthquake around here. So the best thing to do is get to higher ground and then figure out where the shaking happened after. So I think at that, we're going to open it up to some questions and hopefully hear some other people's stories about that day.
Thank you, Heather and Kristina, both so much for that. I have a lot of questions that are stirring in my head. And yeah, if anyone watching has questions, put them in the chat and I will be happy to relay them. I guess I'm a little curious about the video that showed how the tsunami happens. That was using a subduction zone, right, as the example, but you're saying that it doesn't have to be a subduction zone, which we don't have anymore out off at shore in California. It can be any type of fault that could spur that sort of seafloor movement. So
if it's a fault, you really need to get that displacement of the seafloor. You need to change it, make it go up or down or both to generate that wave. So like you said, absolutely, we are now a strike slip system, but we do have we're mostly strike slip, like the San Andreas and the San Gregorio are big strike slip faults, but they do have a little bit of a component that can do this. So it wouldn't be most of their slip, but it could it could be some of their slip. Or an earthquake, a local earthquake that generated shaking could also potentially set off a submarine landslide. It would be another way that that could happen.
Right, yeah, and that canyon is quite deep, as deep as the Grand Canyon, as they say. So yeah, I could imagine a landslide off at sea in that setting being really impactful.
And I should express that, like, as Kristina mentioned earlier, like large earthquakes are rare, and it's not about something that you should worry about every single day. It should just be something that you know what you're going to do if it does happen.
Yeah, and that you're prepared for. And the tsunami that we've been talking about, the earthquake that we've been talking about, did happen quite far away too. So it's not just about the local risks. It's also, there are other areas where it could happen as well. And I'm curious about that map, the inundation map, because the seawall that you showed the picture of in Japan that was breached, that was put up with their plans in place of what they were expecting, like what types of tsunami impacts they were expecting. And obviously they were a little off. So, I mean, do you know how our inundation map was put together, or what they were do you know any background on that?
I don't have too much background on that. I do know the size of the earthquakes that they put into their model, but I'm not a tsunami modeler myself, so I don't have a tremendous amount of details on that. But they were at least the faraway sources, they were modeling quite large earthquakes.
Yeah. Well, and the video that you both showed of the waves rolling in through the harbor too. I mean, it did look obviously like it was causing some damage, but I also think probably like it doesn't look as maybe like wild as it actually was. And that brings up, we had some people share their thoughts with us on social media in preparation for this event. We were just curious what people remember looking back on the 10-year anniversary. And we did get some responses that I just wanted to share, that, seeing people flocking to Westcliff to see it, just like those surfers heading out while the tsunami was literally still happening, walking out into the waves. But then also like people having the complete opposite reaction, driving all the way up to the summit, and noting that it was like one of the most incredible forces that they've ever seen. And I don't know if like one of this person here on Instagram said seeing it in person was next level, and the videos just don't do it justice. So yeah, if anyone joining us like has memories from that you want to share, put those in the chat too. I liked what this one said about watching the SS Palo Alto almost completely out of the water before the tsunami, which it made me think of the big ship that you showed pushed all the way up on shore, and thinking of the SS Palo Alto, like the water being pulled so far out that it looked like it was beached. Much more impactful than some of the images really like make it seem. We did get a question from Hannah saying, do you know what the inundation was like in Santa Cruz from the 1964 Alaska earthquake? Did we get a tsunami from that?
You know what? I looked for that when preparing for this talk, and I did not find any information on that. I did find some information on a previous inundation from a 1946 Alaska earthquake, which was not as large as the 1964 earthquake. And I think it had a sort of similar inundation to what we saw from Tohoku. And I want to say hello to Hannah, who is a former student of mine and who worked on the Tohoku earthquake for her PhD. And now she works at the, can't think of both, Pacific National Labs.
Cool, welcome Hannah.
I'm missing a letter in there.
Great. And then also someone was curious about that ship again. Like do you have a sense of how far inland that ship was carried?
I don't have a total idea of that. It's definitely not right next to the coast. It's like definitely in a neighborhood, but I don't know exactly how far in it is.
Yeah, a really amazing event. And I know that we're in California, we're all acutely aware of earthquakes happening and yeah, hopefully prepared for them. And also, though we probably think more often about effects of earthquakes like what we saw with Loma Prieta and like, you know, buildings crumbling, bridges collapsing. But then there's also, like you brought up, the 1906 earthquake, which was bigger than Loma Prieta, which I don't know if I knew that. But like a lot of the devastation from that earthquake that I recall is actually from like subsequent fires that were caused from it too. And then like what Christine was sharing with Haiti, like a relatively small earthquake causing a lot of devastation because of the infrastructure there. There's just so many things to think about when it comes to seismology. Maybe can you guys share what do you find most fascinating about your field of study?
Christina, you want to take this?
I don't know. I think how complex it can be, like how we're always surprised by the next big earthquake. Yeah. I mean, the reason why the tsunami was so big for Tohoku is because that big slip patch happened right at the sea floor, which people didn't expect. So I think,
yeah, like no one earthquake is the same.
Yeah.
What about you, Heather?
I think one of the aspects that I like the most, I started out studying geology and sort of made my way to earthquakes. And I really love how, you know, we think about tectonics as being this like millions and billions of year time scale, but the earthquake is like most of that motion happening on like, you know, it happens on the scale of seconds and minutes. And I really love the sort of collapsing of those time scales, like thinking like, this is like where the rubber hits the road for tectonics.
Yeah, I do. I love that dichotomy too, that we're so used to like just this time scale that's mind-boggling that you can't really fathom, and thinking of millions of years and yeah, just things that you can't really watch, but then earthquakes are the thing that you can watch. There was some other, let me see, did radioactive debris get from Japan to Santa Cruz? Do you know what the fallout effects were?
The fallout effects are not that widespread. Ocean is pretty big, of course. So there's the dilution factor there. But it's something that's been, I don't have like any numbers specifically for Santa Cruz, but it's something that's been studied. That's sort of how that debris is spread has been studied pretty closely.
Yeah. And then we did have a memory come in, someone hurrying down to secure their boat in Moss Landing. And once I felt it was safe, I sped back to Santa Cruz Harbor to check on my sailboat there. I almost lost her. She held on by one line after the second tsunami wave broke the dock apart while I was on the boat tying up oar lines. So yeah, for that person, for Doris, it sounds like that was a very memorable day and quite a hectic, chaotic day. One of the comments that I saw come in on one of our questions online leading up to this, someone said that they were kind of like not worried about the tsunami like at all and thought people were being silly, but they did make a joke to their friend who had a boat in the harbor at Moss Landing that they'll go find it like in Piscinus or something like that after after it was over. Let's see, someone said radioactive signals were measured at PNNL in Washington. So it appears that there was some.
That's where Hannah works now. So she apparently has more info on this than I do.
Yeah, Hannah, if you like, I could, you don't have to do this, but if you want to talk a little, you can use the little raise hand signal and I can unmute you or like allow you to unmute yourself so you can share a little bit of what you know, but you don't have to. I'll wait and see if you choose to do that. And then Reed said, why was there significant damage at Santa Cruz Harbor, but not a lot of damage at other Monterey Bay harbors?
That is a good question. I think I saw another question sort of related to that, that both Crescent City and Santa Cruz were hit by Tohoku. So what happens like in the local, like, so your wave is coming in, but what happens as it approaches shore has a lot to do with like your local seafloor topography. So you can get things amplified, and Crescent City is one of those places that definitely amplifies things. due to the sort of shape of the seafloor around that area.
Isn't it that like there, like with tidal forces, like some places you get crazy big tidal exchanges because of like the resonance of the topography below just creates, or like the topography creates this resonance with the waves where they like get just like so much bigger in these basins, whereas other places don't have that. Does that sound like maybe a similar?
Right, yeah, how those waves are going on with the seafloor, and remember, like they're rolling in, they start interacting with the seafloor as it shallows, and that can really change how the waves behave. Yeah, and then also, I mean, that that diagram that you showed of the like the gradient of like the power of the tsunami's impacts as it was spreading out, like it did seem that some parts of where it hit the west coast of like North America were definitely more larger than others. Obviously, I would assume that in the Monterey Bay region, it was probably pretty uniform, but that might have something to do with why, you know, different places along the coast of California might have had a different impact. Exactly. You saw like there were like general lobes of color around, like going away from the Tohoku earthquake, but there were like streaks too that could, where the waves got amplified, even like not very close to shore. Yeah. And Doris also shared some insights into this topic too, about like why Santa Cruz Harbor and not these other local ones. And she wrote, because of the way the harbor was created, the tsunami waves came straight into the SC harbor mouth as a direct hit into a narrow harbor, whereas Moss Landing took it sideways and the harbor mouth goes into the slough, dissipating the wave force. The boat docks are at a right angle to the harbor mouth there. The difference was extreme. Yeah, that makes a lot of sense too. And if anyone's been to Moss Landing Harbor, you can like, I can see that now. Like it is kind of more of a maze than Santa Cruz Harbor, which is really definitely like a straight shot. So I could see that. And yeah, notes that there are a lot of boats lost at Santa Cruz Harbor. And Monterey Harbor was also at an angle and didn't take it straight on. Let's see if there are any other questions coming in. You can drop them in the chat. Let me see if I missed any. Yeah, I don't think so. Okay. And it's, yeah, Doris also adding that the surge went on all day. It was pretty scary. And that's, so yeah, speaking of like, yeah, this like this on and off inundation lasting all day long. The tsunami is not just like when the wave is coming in, it's like the waves, you're seeing all aspects of the wave when it's, you know, farther into shore and farther out. It's just a different part of the wave, right? So the tsunami was that in and out that kept happening. Right. It's not just like it all goes in and it all goes out and it's over. Like it can come. It comes in waves doesn't sound like the right way to describe it. It really does. Yeah. And so that, you know, what you were showing, like the very first one that hit that with those, that sequence of images from Cowles, was that though, like the biggest, the umphiest set that we got, and did they just dissipate throughout the day? I would imagine that was, I don't know that for sure, but I imagine that was the one that was the most impactful, and then they got progressively smaller throughout the day. But if somebody here knows different, then I would definitely like to hear about it. And Jackie's curious about the dredging of the harbor, which I know is always like a big topic, that's something that they have to do annually. And if that could potentially have any impact on tsunami, whether it's been like maybe recently dredged or not dredged, or if they didn't dredge it at all. Do you have any thoughts on that? I would say it could affect the topography of the seafloor, but I think Doris actually might know more about this than I do, because she thinks, you know, thinking about the shape of how it's coming in versus like, instead of just going over the seafloor. She says that she thinks that it should lighten the tsunami risk, and it'd be lovely if she wanted to tell us why, but that's okay if not.
Yeah, Doris, if you want to raise your hand, I can allow you to unmute too, so you can share a little bit more. But I guess that is, part of the process of dredging is kind of like pumping out a bunch of sand. Oh, here we go, Doris, you raised your hand. So we're going to give this a try. So Doris, what I'm going to do is I'm going to allow you to talk, and then you can unmute yourself. So you can now do that.
Okay, here we go. So can you hear me now?
Yeah. Hi, Doris.
Hi. So my take on dredging is that by removing that sediment at the harbor mouth, it would allow more water to rush in the channel. It wouldn't be good for the docks and the boats, but it would probably not allow as much water to inundate the land, like the parking lots and come up high, like inundating, let's say, the Crow's Nest, right? Or the houses that are right by the harbor. So
you're imagining like if it got lower there, then like you have something coming in at that height, the height of the wave would like pop down a little bit.
Right, because there's more volume or space at depth for that wave to rush through. But I'm not saying that's going to be better for the boats and the docks.
Yeah, but it's more, it can take on more water, I guess.
Yeah,
without
it would
raising.
take on more water. And if you didn't have it dredged, maybe the surrounding beaches would take more hits. So that those, for instance, those houses on East Cliff Drive, right southeast of the harbor might be inundated, more likely to be inundated that way. Because
that also makes me think of just like the harbor in general when it was put in. Like, I don't know if any of you have been around Santa Cruz for a really long time, but like Seabright Beach was not the beach that it is today before the harbor was put in. It was a very small little beach. And because of that, there's a lot more sand that collects there, and it's this huge thing. So yeah, like if the harbor wasn't there at all, the museum, for instance, would probably be much more at risk of being impacted by a tsunami, I would imagine, because we'd be right there.
Yeah,
you guys are right there.
Okay, well, thank you, Doris. It was great to hear someone else's voice. If anyone else wants to chime in, you can raise your hand, and I can give you some talking permissions. It's a fun little feature. But I think we're getting to a close time. I did want to share some more links with you all. So there is a website for the Seismology Lab where Heather and Kristina work up at UC Santa Cruz. So if you're interested in learning more about their laboratory, where they do their work and what types of work they do there, you can explore that website. I will be sending out a follow-up email after this with some resource links that Heather and Kristina are going to share with me. I'll also share a link to watch the recording of this lecture. And there will also be a link to a survey. And I'm going to just go ahead and put the survey link in here now as well. We'd love to hear your feedback so that we can continue to make our programs better for our community and meet your needs. So if you have a moment, please do consider filling out that survey. And Heather and Kristina, do you have any parting thoughts that you'd like to leave us with?
I don't think so, I do. Thank you everyone for coming.
Yeah, thank you.
Okay, well, thank you both. And I'm really looking forward to continuing to partner with the Seismology Lab on future programs, maybe even some like outside walks when the timing allows would be fun. But yeah, so thank you both so much for sharing your time and your expertise with us. And thank you to everyone who tuned in tonight. And you will be hearing from me in an email soon. Have a good night.
Thank you, Marisa.
Thanks. Bye, everyone.